In this video, I will be going over lesson 5, solving equations. Okay, so really quickly, when we are solving equations, what we want to do is use inverse operations. And inverse operations mean we want to undo the math that we are seeing. So say we saw a problem that had addition. Okay, to undo that addition, we want to do the opposite, which is subtraction. Same thing with multiplication. If we see multiplication, in order to undo that, we want to divide. With subtraction, to undo that, we want to add. And then for opposite of division is going to be to multiply. So you'll see what I mean when we start doing some examples. Okay, here are our first examples. On this first one here, I have 3 times x. So anytime you see a variable that is right next to your number, like here we have this 3 and x, that represents multiplication. So in order to undo this multiplication, we want to use division. Remember, opposite of multiplying is dividing. So we want to divide this by 3. Okay, so my goal is to get x by itself. So by dividing by that 3, that's going to cancel my numbers and it's going to leave me with just my variable. Now, anything you do to one side of your equation, you have to also do to the other. So see this equal sign in the center is kind of like a line and it divides our equations in half. So anything you do to one side, you have to do to the other. These 3's right here are going to cancel, leaving me with just x. And then 15 divided by 5. Oops, not 5, that should be a 3. It's going to be 5. So here x is equal to 5. On our next example here, I have x minus 2 equals 6. So here this minus 2, this represents subtraction. Okay, so I want to undo that subtraction to get x by itself. The opposite of subtracting is going to be adding. So we're going to add 2. Remember that anytime you do any type of math to one side of your equal sign, you have to also do the same to the other. So since I added 2 over here, I need to add 2 over here. These are going to cancel, and I'm left with just x on this side. And 6 plus 2 is going to give me 8. All right, our third example here, I have x plus 6 equals 20. So here I see a plus 6. The opposite of addition is subtraction. So I'm going to subtract 6 here. I have to do the same thing to the other side. So these are going to cancel. I'm left with just x. 20 minus 6 is going to be 14. All right, let's move on to two-step equations. And with two-step equations, we want to work furthest away from the variable and then slowly work our way towards it to get it by itself. Okay, so again, I'm going to start the same way by kind of using that equal sign to cut my equation in half. Now, I can see my x is attached to this 1.5 here. So I don't want to touch that 1.5 yet just because it's closer. Let's look at this 3.9 right here. And with this 3.9, I see a plus sign in front. So the opposite of adding 3.9 is going to be subtracting 3.9. Now, I'm subtracting 3.9 here, okay? So that means I have to also subtract 3.9 on this side. These two here, if I have 3.9 minus 3.9, that gives me 0, so these cancel. I'm left with this 1.5x. And this is equal to these two subtracted. Now, I can use a calculator to help me with my addition and subtraction, especially when I'm dealing with decimals and with fractions, just to make sure I'm getting the correct number. So when we type this in, we get a 4.5. Okay, our next step. So I have this 1.5, right? And I need to get x by itself. 1.5 is being multiplied to x, so the opposite of multiplication is going to be division. So we're going to divide both sides by 1.5. Remember, anything you do to one side of your equal sign, you have to do to the other. So these are going to cancel, and I'm left with x equals 3. And again, you can type this into your calculator if you would like to double check. And when you do that, you will get 3. All right, take a look at this one here. This one's a little bit easier. We don't have any decimals or fractions. So I have negative 5x minus 13 equals 12. So again, we're starting furthest away from the variable. So we want to get rid of this minus 13. The opposite of subtracting 13 is going to be adding 13. Now, if I add 13 here, I have to also add 13 to this side. So these are going to go away. This minus 5x, I'm going to bring down here. It's going to be equal to 12 plus 13, which is 25. Okay. From here, I can see that I have multiplication. I have this minus 5x, and that's equal to, 25. So I'm going to divide by this minus 5. And the reason why I'm dividing by this minus 5 is because if I were to just divide by 5, this minus sign here would still be here. And that means x isn't by itself yet because I would still have to get rid of it. So I want to divide by a negative 5 so that way they both cancel. So I'm going to also divide this side by a negative 5. So this is where I would recommend double checking your sign by typing this into a calculator, because this is where a lot of students can make a simple mistake. So 25 divided by negative 5 is going to give me a negative 5. So again, don't be afraid to double check your arithmetic and your calculations with that calculator just to make sure that we're on the right track. Okay. So here's our first question from workbook 5.1. It says, what are the correct steps to solve the equation 1.5x plus 3.9 equals 8.4? Well, if we think back to what we did on the previous slide, I want to work furthest away from the variable first, which means this 3.9 I want to get rid of first. And I see a plus sign in front, which means I need to do the opposite, which is subtracting a 3.9 from both sides. Okay, so these down here that say we're adding, these I'm going to cross out because I know I need to subtract, and I'm subtracting 3.9 from both sides. So that means that I already know that A is the correct answer because B says we're subtracting 8.4, but that's not what we want because we want to get rid of this 3.9 that's on the same side as this variable. So first we would subtract 3.9 from both sides, then we would divide by 1.5. Our next one says solve the equation. What is the value of x? Okay, this one looks a little bit tricky because we do have this fraction here, but remember it's not as bad as we think it is. Okay, so let's draw our line to cut our equation in half. Whoops. There we go. Okay, so I have this minus 4/5, and I want to try and get rid of that. The opposite of subtracting 4/5 is going to be adding 4/5. And remember, anything I do to one side of my line or my equal sign, I need to do to the other. So I know these are going to cancel, and I'm going to be left with just this 3x on this side. Okay. Now I have these numbers here. I'm going to pull open my calculator to help us solve this. Okay. So I have a negative 12. Don't forget this minus sign because that does make a difference. And I am adding 4/5. So I'm going to be adding 4 over 5, and that gives me this negative 11.2. You can change this into a fraction if you want, but I think it's a bit easier to leave it as a decimal. Either way, we're going to be using our calculator again on our next step, so whichever way you prefer. I'm going to leave it as a decimal, negative 11.2. So now when I'm looking, I see that 3 attached to my x here, which means that I need to get rid of this 3. So opposite of multiplication, opposite of multiplying is dividing. So I'm going to divide both sides by 3. When I do that, x is by itself, and I have this negative 11.2 divided by 3, and we're going to type that into a calculator. So negative 11.2, and we are dividing it by 3. That gives us this negative 3.73. We can see how that 3 repeats forever. We don't need to write all of the 3's. You know what? I see what I did here. So I was just double checking with the course because I wanted to see if they left it as a decimal or a fraction. And it looks like when I rewrote this problem, I forgot to change this 12 to a 1/2. So what we're going to do is we're going to leave this here, and we're going to just resolve this one with the 1/2. So the one I'm writing in blue here, this is the course question. I apologize. I was wondering why they gave you why it was that weird decimal. This makes more sense now. It's just extra practice. All right. So again, we're going to start out the same way by adding 4/5 to both sides. So the process is still going to be the same. We just have a 1/2 instead of a 12. I'm still going to bring my calculator, and I'm still going to type this in. So I'm going to have a -1/2, and I'm going to be adding 4/5 to it. And that's going to give me this 0.3. Then to get rid of my 3 attached to my x, I need to divide both sides by 3. And when I do that, I get either 1/10 or 0.1. So either one of those answers will work. So 1/10 or 0.1. And again, if you wanted to double check, you can type this into your calculator to make sure we're getting the right numbers. All right, next question says that Dax is buying coffee for 5 people in his office. He also leaves a $2 tip for the barista. If his total with tip is $18.25, how much is each cup of coffee, not including the tip? Okay, so Dax here spent a total of $18.25. So think about like if you went to this coffee shop, okay, and you bought, say, I don't know, 5 cups of coffee for the 5 people in your office. So each of those cups of coffee is going to cost the same. And then that tip I'm leaving at the end is something extra. Okay, so if I wanted to figure out how much I'm paying just for the coffee, I need to figure out how much I'm paying without my tip. Okay, and he tips $2. So first thing we want to do is subtract that tip from how much he pays so we can figure out how much he's paying just for the coffee. So when I do 18.25 minus the $2 tip, I get $16.25. So now I'm going to take that $16.25 and I need to figure out how much he's paying for each cup of coffee. Well, I know this is how much he spends in total for his coffee, okay? To figure out how much he spends for each cup, I need to divide it by the total number of cups he bought. And it says here he's buying coffee for 5 people. So I want to divide this by 5. And I'm going to pull open that calculator to help us here. So I have 16.25 and I am dividing that by 5, which gives me 325. So this means that Dax is paying $3.25 for each cup of coffee, not including the tip, because we subtracted it right here, so that's why it is not included. So $3.25. All right, our next topic for lesson 5 is going to be distribution problems with equations. So here it's very similar to what we were doing in the first, or 5.1, except now we have to do one extra step, which is we have to distribute first, then we can solve our equation. So remember, when you're distributing, the number outside of your parentheses is what you want to multiply in. So this 3 out here is going to be multiplied to both the x and the 8. 3 times x is 3x. 3 times 8 is 24. And this is equal to 39. So from here, to solve this, I want to work furthest away from my variable. So I want to get rid of this plus 24 first. The opposite of adding 24 is going to be subtracting 24. I can't forget I also need to subtract 24 from this side. So when I do that, these are going to cancel, and I'm left with just 3x. And then 39 minus 24 is 15. Opposite of multiplying by 3 is dividing. So this means x is going to be equal to 15 divided by 3, which is 5. All right, here's another example. So again, this time we're taking this -6 and we're multiplying it in. -6 times x is -6x. -6 times -14 is going to give us a positive number. And again, if you want to double check, you can type this into a calculator. So -6 times -14 is 84. And the reason why I'm saying -14 is because this minus sign right here in front of the 14 makes it like a negative number. So this is going to be 84, and that's equal to 72. So now opposite of adding 84 is subtracting. We're going to subtract 84 from both sides. I'm left with a -6x, and this is going to be equal to, and again, remember that when you're subtracting, your order of the numbers matters. So here 72 comes first, and I'm going to subtract that from 84. That's going to give me a -12. So I want to divide both sides by -6 to get this x by itself. -12 divided by -6 is +2. Okay, so again, these questions are similar, except we have that one extra step where we have to distribute our numbers first. Okay, so here's our first question. It says there are two different ways to solve this equation, and we want to select the two answers that apply. So the first way we could do this is just by doing our normal distribution first. Right? So if I wanted to take this 5 and multiply it into everything, I would get 5x plus 15. So the first way is going to be to distribute. So let's read through these. So first simplify the left side of the equation by distribution, then subtract 15. So this is correct because once I do that distribution, I do want to get rid of this 15 here. So the one that has that subtract 15 is the correct one. Now with these ones, there's another way of doing them. So if I have this 5 times x plus 3 equals 25. So this 5 technically is being multiplied here, right? I just said 5 times this whole thing. So the opposite of multiplying is dividing. And if I divide this side by 5, what happens is these will cancel, but I have to also divide this side by 5. So then I'm left with x plus 3 equals 5, because 25 divided by 5 is 5. So I would divide both sides of the equation by 5, and then I would subtract 3 from both sides of the equation. So those are the two ways that we could solve this problem here. All right, next it says solve the equation, what is the value of a? So here there's two different ways we can do it. I want to do the distribution first just because I prefer that method. If you want to do the other one, that is fine. You'll get the same answer both ways. So 2.25 times a, so 2.25a plus, and then I have this 2.25 and I'm multiplying that by 1.3. So 2.25 times 1.3, and that is going to give me 2.925. And I want to keep all my decimals here all the way till the very end. Okay, drawing my line to cut my equation in half, I want to get rid of this 2.925 on both sides. So here's where it's very helpful to make sure that we are utilizing that calculator just to make sure that we are having our decimals line up when we're doing our subtraction and we're keeping the same answer or the correct one. So I have 20.7 and I'm going to subtract that from 2.925. When I do that, I get 17.775. Okay, from here, I need to get rid of this 2.25. Opposite of multiplying here is going to be dividing. Let's divide both sides by that. I'm going to type that into my equation, or my calculator here, so 17.775, and I'm going to divide it by 2.25, which gives me 7.9. So here A is going to be equal to 7.9. Now again with the decimals, remember that as long as we know where we're subtracting, what opposites we're doing, we can always type it into a calculator just to double check our answers. All right, last question here. So Sophie is buying 3 outfits, shirts and shorts to wear to volleyball practice. The shirts are $10 each, and her total is $64.50. How much did each pair of shorts cost? Okay, so she's buying 3 outfits. Okay, so she's going to buy let's see. So she's going to buy 3 shirts. I'm going to try my best to draw 3 shirts. There we go. And then she's going to buy 3 sets of shorts. Oh, it's like the more I do it, the more my brain doesn't want to. There we go. Okay. Each of the shirts are $10. So she pays $10 for this, $10 for this, and $10 for this. So just on her shirts alone, 10, 20, 30, she spends a total of $30, okay? Just on her shirts alone. She pays a total of $64.50. So to figure out how much she spent just on these shorts here, I need to take this $64.50 and I want to subtract the 30. So I'm subtracting how much she paid for all 3 of her shirts just to figure out how much she's paying for her shorts. So when we subtract that, we get $34.50. Now I know that she is going to pay the same amount of money for each of her pairs of shorts, right? And she bought 3 of them. So to figure out how much she is paying for each pair, I want to take this and divide it by 3. When I take this and divide it by 3, if I were to type this into a calculator, it would give me 11.5, which means that she is spending $11.50 for each of those pairs of shorts. So each pair of shorts is $11.50. All right, that is it for lesson 5. Please let me know if you have any questions.